So my take would be focusing on rivers as early warning system and what a decade of stream flow decline tells us. To start off, I will begin by sharing the general knowledge around water as a commodity. Uh, well, we all know that water connects all sort of resources um, on the planet, be it from plants, animals, people, whatever it is. But the known information relating to water is that it covers about 70% of the surface of the earth. And of the 70%, majority or large proportion of the volume of water is found within our marine resources. Only 3% of the available water is found as fresh water. And within this fresh water, majority is in the form of ice, 30% in the form of groundwater, and only 1% is available as surface freshwater resources. And let me break it further down. Within these freshwater resources that we have on the surface, majority of this volume of water is in the form of lakes. Um, Only 2% is found in rivers and about 11% in wetlands. So having set that particular background, we can really see that we really don't have much water available for use, particularly that is fresh water. Then let me even bring it closer to home and dissect what we call strategic water source areas. These are actual areas within, South Africa that have high water yield potential. And this is very important for national water security, as these particular areas have high potential to support what we call socioeconomic development of the country. Okay, so from what is of interest from this particular Stats SA report of 2023 was how they actually dissect this surface water availability in South Africa per region. Let's look at the KZN region where majority of our freshwater resources are found. About uh, more than 30% of the available water resources are actually located in that region. And looking then it's Mpumalanga following to KZN, then Western Cape and Eastern Cape. Of interest, ladies and gentlemen, is the fact that Gauteng doesn't even have this strategic water resource to support um, different economic activities that are happening there. I mean, it's a subject on its own how they actually get to support that industrial hub which they have given the different water transfers that comes from other areas such as Lesotho. But it is of interest that in that particular region there's just no natural supply of water other than perhaps water which is pushed in that particular region. So that is how the natural surface water um, is distributed within that particular or within the South African context. So again, this particular water uh, that we have, and again, being a limited resource already, um, majority of what we have in South Africa, we use that for agricultural purposes, and about close to 30% for domestic uses. And it is important to actually say that the current water demand far surpasses the supply, which even adds on the actual stress that we have as a country, that we are tending to use more water than we have. And again, having set that particular background that I've painted on in the previous slide, that we actually don't have much water. So this actually exacerbates everything water related, that we actually don't have um, enough water available for either supporting our socioeconomic activities that we do. And again, predictions are that um, in 2040, this will worsen by 36%. So it means that there would be more high demand by 36% in 2040 than we have currently. And looking at the gap between the existing supply and the projected demand, in that particular map over there in the screen, we can see that it is only within the orange catchment where in the coming decade or so, um, there would be surplus water supply. The rest, if you can see the dark green color there, which covers Olifants, Inkomati, Upper Val, Tukela, we would actually be lying uh, at a space where we actually um, short between -20 to -80% water compared to the demand that will be there by the time. So it's actually giving a not so good picture as far as water projection is concerned going forward. Not only is water, changing for the worse in terms of quantity and availability, but also in terms of climate change prediction. Let's look there on this particular slide there. In the worst case scenario, I know there are different models, but in the worst case scenario, in 2050, we might be, climatic wise, we might be lying in or with an increase of about between 5 to 8 degrees Celsius. So that would, given the picture I painted earlier, that would again exacerbate the current condition as far as water availability is concerned. And I do know that there are local variability or variation as far as predictions are concerned. Though there are areas, there would be areas that becomes slightly wetter, but in a bigger chunk of things, we are most likely to be experiencing drier and hotter conditions, which would demand more water uses, and also to support um, agricultural activities, and also the different other socioeconomic uses. Okay, again, zooming in into the current condition, let's look at the Blue Drop report from 2023. things are not looking right, even in that particular area. About more than 60% of the wastewater treatment plants, are on the verge of collapse or failure, as reported in that particular report. And about more than 50% of municipality don't report crucial information happening with, the domestic water supply, such as perhaps contamination that usually happens within the um, water supply space. So it's also not looking good. And looking at the green drop as well, as far as compliance is concerned, relating to uh, the different discharge standards, it's also not looking good because the limited water resources, surface water resources that we are actually contaminating uh, those legal resources that we have more. From the same year report, 2023 Green Drop report, reporting that from about 850 wastewater treatment works, about more than 300 don't actually comply. So this really gives another layer of you know stress that the resources already has, given that the demand is already high. So now I actually haven't painted that particular picture of how, you know, the situation as far as water availability is in South Africa. I want to zoom in into this particular case study of this particular strategic water source that I've studied for the past, or observed for the past 10 years. So it's the Ruvubu River catchment, wherein I have um, long-term sites that I'm actually monitoring in a seasonal basis. So that particular region, it's actually a very pristine region, particularly at the top of the catchment, where majority of the streams originate from. However, um, there are actual changes that are starting to occur in that particular area. And then this speaks to the availability of water. You'll see in the coming slide how things would change or are changing in the past 10 years. So I have this particular video that I want to share of how land use or land cover has changed in that particular area where I have actually circled in that particular color. If we can keep our eyes there, you will see the changes that have occurred from 2013 to about 2022. Okay, I'm just gonna click there and it will roll. Okay, so what have happened in that particular area? It's at the top of the catchment. However, the level of deforestation that is happening in that particular area clearing of the natural spaces and being replaced with either, you know, uh, pine plantation or other agricultural activities such as, commercial banana plantation, macadamia. There's just a number of agricultural activities happening in that particular area, but the natural spaces, the natural patches that were actually the main dominant cover of that particular catchment, which I do believe that that actually gave breath to that particular strategic water source area, that particular area or those natural spaces are being replaced over time. Okay, let's move on to the next slide. Then not only is the natural cover being replaced, again, we have issues with the encroachment of alien plantation or woody invasive plants. In that particular catchment, if we can look at, at, at that particular figure there, the first bar on your left, it's that particular catchment. And we can see that about more than or 15% of that particular catchment has been invaded or encroached by different pine, gums, bugweed. You mentioned them, different woody plantation as well, which are also contesting for this particular precious and limited commodity that support that particular catchment. And the recent report, Water Research Commission report on uh, different um, infestation of alien plants in that particular region and even others indicate that just the different what we call woody groups of plants that are there, they are just enough to extract water that can even support. If you can see, look at those at the bottom figure there, those little droplets that are indicated there. So that is the amount of water that these particular uh, uh, woody plants extract from those particular, and each one of those enough to can support 7,000 household. So that is just the quantity or the volume of water which this particular um, alien trees, extract from these um, strategic water source areas, and of which, if things were to be kept natural, that would just be the reverse course to say that would be how much water we have in our catchment. Okay, as far as the decline in stream flow is concerned, I have actually uh, observed or measured changes as far as the volume of water is concerned. Okay, these are just three of the many um, measuring points or stations that I've observed in the past 10 years. So all these are at the lower edge or the downstream side of that particular strategic water source area. And you can see all of them are just pointing down. So there's, in the past 10 years or so, or 20, there's just a very high decline, of which some it's even, um, you know, times two as far as how it's declining compared to others. The bottom right pictures there, actual pictures that I took from one of these particular streams. In 2016, we have actually observed a very minimal flow, but as we returned again in that particular site, the very same site, um, some years later, the stream was dry. So these are the different changes that are actually happening in that particular space. So as far as I think this is my last slide or second last, as far as monitoring of aquatic health is concerned, we also do um, different assessment. One of those is checking the aquatic insects and how that translate to the natural integrity or the natural health of those particular sites. So this one, I think it's in the Ruvubu River. Over time, it has actually shown um, improvement as far as diversity is concerned in that particular site. But what was worrying was that over time we're starting to find uh, species that were not naturally adapted to live in that particular area, and these are actually uh, species that are not so good indicators of good health. So hence that particular in the figure there, if you look at SAS 24, that is the measurement that we have done in 2024, which is last year. So we're starting to see even um, in insects that actually are a good indicator of bad you know, habitat condition starting to, um, you know, uh, creep into um, those particular spaces of land or habitat within the different streams that we monitor, which is not a good indication, because in the past you would not have those, you would only have species that are of good um, indication as far as um, ecosystem health is concerned. So my concluding remarks relating to this particular situation of water availability is that we actually need long-term monitoring of rivers, and also to integrate citizen science as far as monitoring of our rivers or freshwater resources is concerned. This speaks to the integration of local communities, given that maybe institutions that are actually mandated or responsible for this long-term monitoring sometimes find themselves without good capacity, human capacity, to undertake all this extensive monitoring across the board. So we need local communities to actually help us track the state of our rivers, because rivers are actually the primary indicators of how things are as far as the quantity or the availability of fresh water is concerned. And I think it's about time that the um, agricultural sector as well shifts the practice and adopt what we call climate resilient agriculture, because the times we are living in, you know, it's changing for the worse. The quality, the quantity of water getting degraded and worse, and climate-wise, things not looking good. So we also need to change the focus in that particular sector. And again, as far as um, monitoring is concerned, I think there need to be investment as far as clearing of alien invasives in the different strategic water sources that I spoke to earlier. And again, compliance. I think I can't even emphasize this enough, that we do have good policies. We do have good infrastructures sometimes, if not that over time they do as well come or degrade. But there has to be some level of enforcement and compliance that is enforced in these particular sectors, particularly looking at wastewater treatment works or plants. So there has to, discharge what is acceptable to the environment. And then I think again, I have already alluded to this, that there has to be a partnership with local communities so that they become, our observers on the ground, and using the citizen science, the normal or the low cost science that, even untrained people can do. However, we still need more expertise around, different different sectors within the water space. We need people who would, do extensive and large scale modeling, as far as data is concerned, as far as spatial scale is concerned, to predict what are the likely course of things going forward. So those are my remarks, and in a nutshell, my take as far as the general state of things relating to the availability of water, particularly surface water resources, particularly looking at the quantity um, side of things. Thank you so much, Chair, for this opportunity to share my thoughts. Thank you so much.